Okay. So when we're balancing equations, this is the type of problem where I like to divide it in half. So you find your arrow and divide it in half. This separates your products from your reactants. Say that backwards, sorry. Reactants, products. This one might look trippy because it's going backwards. You have one thing and now you're making two things. That's okay. Still a chemical reaction. So let's start by writing what we have. On this side of the equation we have Hg and we have O. Over here we have Hg and we have O. Okay? So how many Hg's do I have on this side? One. How many O's? One. How many Hg's do I have on this side? One. This should have a little 2, shouldn't it? And how many O's? 2. I was going to say, I gave you one that's already balanced, but no, I did not mess up. Alright, so which part of this needs to be balanced? O's. We have 1 over here and 2 over here. We need them to match. So what can we multiply this 1 by to get it to 2? Perfect, a 2. So if I put a 2 here, remember that 2 goes to everything. So now I have 2 Hg's, not 1. And now I have 2 oxygens. So am I done?
No.
What do I gotta do now? Perfect. Over here I only have 1 Hg. Over here I have 2. So I need to multiply this by a 2, and I put a 2 here. Anything you're multiplying by goes up top, the big numbers. And my 2 times my Hg gives me 2 Hg's. So that's my answer. 2 HgO yields 2 Hg's plus O2. If you don't like blanks and you want to put a 1 there, you can, but you don't need it. Okay? Let's do another one.
So, completely unrelated question,
What?
but what is a molecule with H4O2?
Oh, I don't know its name.
No, that's-
Some kind of peroxide. But anything with O2 is some kind of peroxide, but I don't know its name. Probably something super that cleans really good. Alright, let's see what number 2 is. FeO2, Fe2O3. Okay. Alright, so for this one we've got Fe plus O2 is going to yield Fe2O.
You guys remember it?
A little bit, you're fine. That's how I wrote that right, correct? Okay. Alright, so here we go again. Dividing it in half. I got Fe on my reactant side and an O. And over here I got an Fe and an O. So on my reactant side, how many Fe's do I have? 1. How many O's? 2, because they're a little 2. Over here, how many Fe's? 2. And O's? 3. Okay. A hint. When you're balancing equations, don't start with oxygens if you can help it. So do everything first, then do your hydrogens, then do your oxygens, because they get crazy sometimes. So let's start with our irons. If I have 1 on this side and 2 on this side, what can I do? Very good. Oops. Multiply this by 2, so I put a big 2 up here. Now instead of 1 Fe, I have 2 Fe's. So my Fe's are balanced. Now we've never had one with a 2 and a 3 before. Because you can't multiply 2 by anything to get 3, and you can't multiply 3 by anything to get 2. Perfect. So you're going to use 6, least common multiple, which I'm sure you've heard of math. So we're going to get both of these oxygens to 6. So how many, or what number do I need to multiply 2 by to get to 6? 3. So I'm going to put a 3 here. 3 times my little 2 gives me 6 oxygens now. Perfect. Over here I have a 3, so I'm going to put a 2 to multiply it by 2. And my 2 times my little 3 gives me 6 oxygens. But what else does this 2 do?
Makes Fe4 over there.
Yes. So it goes to everything. So it goes to our 2 FEs, and 2 times our 2 makes, now we have 4 FEs over here. So then over here, this is where we need to be careful. You want to multiply it by 2, but remember you're multiplying by these little numbers that are down here, which is in a 1. So what number do I need to put here? 4. Yep. It's a common trick to always want to multiply these numbers down here by something, but these are just your brain showing you where you're at. Remember, you're always multiplying by the little numbers. And there's your balanced equation.